Hello, good day. Welcome to the next learning session of the subject construction cost and engineering. Wherein we learn how to cost the certain project and how we deal with the various costing problems. Okay, and also estimating and quantity surveying. Okay, so now let's go to our presentation. Okay, so parametric estimating is a statistics based technique to calculate the expected amount of financial resources or time that is required to perform and complete a project, and activity, or a portion of the project. Okay, so this is the way on how we do the parametric estimating and its definition. Next is the determination of an estimate is based on a statistical or assume. Okay, so when you say assume, it's not assumption that is far from reality. Okay, so it is an assumption which is realistic. Okay, so because we need to be realistic on this because it involves cost. Okay, so we need to be reminded that cost is very important in a certain project or the financial capability of the contractor. Okay, the next is the correlation between a parameter and cost or time value. This observed correlation is in scale to the size of the current project. Okay, so for instance, in highway construction, the cost and time to build 1 mile in a previous project could be the basis for calculating the resources and schedule of uh, the current construction project. Okay, okay, so however, this requires that there is evidence. Okay, so since we are engineering, so needs figure our data. So it's the statistical evidence of the correlation and if the characteristic of both projects are comparable. Okay, so we need to uh, uh, put always in our mind that in costing projects, we need to we need to see that those projects have a certain comparison, or if not, you need to adjust in your costing. Okay, and identify those things that need to be costed. Okay, then while parametric estimation is a common technique to estimate cost in different levels of granularity. Okay, so the form of its implementation varies greatly. Okay, then we are now on the one subtopic of this learning session 2, which is the deterministic estimates. Okay, the deterministic result type of the parametric estimation is a single number of the amount of cost or time needed. Okay, then calculated based on parametric scaling. It is sometimes manually adjusted to account for differences between the current and historic projects. Okay, or to add a contingency reserve. Okay, so that's why in estimates you always see contingency cost, which is uh, computed via a percentage. So I think in my projects, if I'm handling or estimating, I'm using a 5% in my contingency cost. Okay, so it depends if uh, there are clients or owner who wanted to reduce some cost, so maybe you can lower that down, the percentage of the contingency cost per the discipline or the work breakdown. Okay, then the next is the probabilistic estimates. Okay, so this results type is not producing a single estimate but arrange estimates based on the probability of different cost and duration amounts. This often presented in the form of a probability density curve as shown in the below chart. Okay, so this is the curve. We are all familiar on this one in our statistics subjects. Okay, so this is the curve. So as you can see, uh, there are points on where we decide our estimates. Okay, then a method to convert this function into a more practical range of estimates is the identification of 3 points on that curve. Okay, the most likely estimate, which is normally the cost or time value with the highest single probability. Then we have the pessimistic estimate and the optimistic estimate. Okay, so the optimistic and pessimistic cost and duration estimates can be determined by defining a target probability. For example, we have 90%, 95, or 99%. Okay, subject to the quality of the underlying data and the type of the value distribution, and or multiplier to their standard deviations. Okay, so depending on the form of the probability density curve, these 3 points can then be transformed into so-called final estimate. Okay, so in that way we can produce a certain cost of the project when we already know the transformation of this final estimate. Okay. The next one is the parametric estimating procedures. Okay, so this is the method on how we conduct parametric estimating. Okay, so number one is we have to determine the parts of your project for which you can potentially use a parametric estimate. As a first step, the project manager needs to identify which portions of the work there is the selection criteria are mainly. Okay, so number one is a required level of accuracy. Okay, so the main issue on the this kind of estimate is the uh, accuracy. Okay, so number two is the correlation of parameters and values, availability of data for parametric estimation. Okay, so number two, we have research, historic, and market data on the cost and or the time requirements of similar projects. If you have identified areas for which parametric estimation could be applicable, you need to gather the relevant data. Potential data sources are internal cost, time, resource databases that are fed with observed values from previous projects. Publicly available data such as public statistics or industry benchmarks. Okay, so we have number three. Identify the parameters that you wish to test for correlation with the cost or time values. Okay, once you have created a set of data, you need to select the parameters that could potentially correlate with the cost or time requirements. These correlations will be subject to further statistical analysis if you are using a model for this one. Okay, so in smaller projects, you would probably apply expert judgment or common sense to decide which parameters would be reasonable. If this suffices the needs of your project, you can skip the next two steps and move on to the calculation section. Okay, so number four, determine the parameters that drive cost or durations. Example, through a regression analysis and further statistical analysis needed. Okay, so we have to test the set of parameters identified in the previous step for correlations and or regressions. This will usually involve the use of the software, the statistical software as R or other free or commercial solutions. Okay, so those are the steps. The use of the AI or the computer in estimate can also be considered example to identify patterns in complex datasets. Okay, so since we are in the century where computers are very important and almost all industry uses computer, all analysis, whether you're a civil, there's STAAD. Okay, so I do not know with the other courses, but one common computer aided software that most engineers use is the CAD or AutoCAD. Okay, so AutoCAD is used for drawing. Okay, so it also same with estimating. So there are many um, software for this one, but we need to understand that in estimating we cannot just rely all our analysis to the AI because more importantly the experience is very important, and the let us say how you judge your project, it depends on how you see the site. Okay, so that's the things that an AI cannot see. Okay, so that is why we need to have a good estimator with experience. Okay, so for different kind of discipline. Okay, so because there are many estimator, example for civil there are civil works estimator, then we have electrical and other discipline that you need to cost. Okay. Okay, the next one is the for complex estimates, projects develop a model, perform backtesting if possible. Also develop a model to predict the cost and durations amounts of your projects based on the set of parameters that have been identified in the previous step. Make sure you test the results again, historical data. Okay, so we are now on the fourth subtopics of this learning session, which is the what are the advantages and disadvantages of parametric estimating. Okay, so advantages. Okay, so this is the pros. Okay, so the good thing about things about parametric estimation. Okay, so the parametric estimation technique can be very accurate. Okay, when it comes to estimating cost and time. Number one, because it uses the statistical analysis. Okay, for this one, then uses historical data which be computed through statistics. Okay, so that is why it's more accurate. Okay, using these kind of estimates. Okay, so it is therefore easier to get stakeholders support and approval of budgets determined this way. Okay. Next is once the model is established, it can be reused for other similar project, and the quality of data becomes better with every additional project. Next is a manual adjustment to the calculated results to account for differences between historic and the current project can help address weaknesses of a model or underlying data. Example, if qualitative and environmental factors are not fully fed into the model. Okay, so next is the disadvantages or the cons that we need to know about parametric estimating. Okay, so number one is it can be time consuming and costly. Okay, so then obtaining the historic data and building a model requires some efforts and resources. Then the required availability of historic data and the expected scalability are further constraints for the use of this technique. Okay, so next is it can often only be used for some parts of the project while others need to be estimated with different techniques. Okay, so next is relying on the data may not be appropriate if certain factors differ between the current and previous projects. Aspects such as the experience of the personnel, the progress of the learning curve, we have environmental factors and other criteria may not be fully reflected in a model, thus the reliability of calculated estimate may be affected. Next is the quality of the historic data may also be an area of concern in some cases. The saying garbage in, garbage out applies to parametric estimating the same way it is true for any other use of data. Okay, so next is the parametric estimating has the inherent risk of providing a false sense of accuracy if models are inaccurate or data from other projects are proved not to apply to the current project. Okay, so we have one example for this learning session. Okay, so this is the situation of the problem. The project team in a construction company is asked to estimate the construction cost for a new office building. Okay, then the company has completed similar projects over the last couple of years. Okay, it uses an in-house database to granularly track the duration and cost of previous projects. Okay, so as you can observe, the company of this problem has good documentation system. Okay, so if you are on a construction industry, the system needs to be intact. Okay, so that is why some contractor or company uses the ISO or the international standard organization to have a better file of documentation. The purpose is like this one. Okay, so meaning this will be your basis for your new projects. Okay, so the good thing for this one is you are doing something to prevent problems in your project. Okay, so especially if you are if you have big projects, it costs millions of pesos. Okay, so we need to be very particular on this one. Okay, so that is why the documentation of projects is very important. Okay. Okay, for an initial estimate, a rough order of magnitude, the company intends to use parametric estimation with the building cost uh, per square foot as the relevant input parameter for the parametric estimation. An estimate shall then be calculated with the rule of three. Okay? For similar types of buildings, the average construction cost amounted to 200 per square foot in the past. Okay, so this is your the historical data of the company. So meaning in their previous projects, the cost of their let us say estimates per square foot is 200 pesos. Okay, so this one is the most essential or important data that need for this estimation technique. Then the new building is supposed to have a total area of 3,000 square feet. Okay, so if you have 3,000 square feet, so the this one is equal to the parameter value in the new project. Okay, so this is the parameter square feet or the floor area. Okay, then the calculation of the order of magnitude of the construction cost using a parametric estimate deterministic. This one is deterministic, determined with the rule of three. Okay, so this one is the rule number 3 in our previous discussion with this learning session. Okay, so the computation is this very simple, very short, but the situation or problem is very long. Okay, so that's the good thing for this one. Okay, because there are ways to minimize your um, let us say time. Okay, the usage of time. Okay, so this is the way how to compute that one. Okay, so estimating financial cost we have 200. This one is from the focus projects. Okay, so if you have more projects, then that's good. You can get the average of that one, or you can get the highest. It depends on your judgment. Okay, so but the good, I think the very reasonable way to do is use the highest of your previous uh, projects. This is to be safe. Okay, so in terms of the changes of the cost, especially on materials and labor. Okay, so So this is the computation. We have 200 pesos times 3,000. This is the parameter square feet. Okay, so the answer is 6 million. Okay, so that's the way to solve the parametric estimate using a deterministic approach. Okay, so that's how you do it, class. The estimate is simple for this one. This is not detailed, so it uses data of the previous projects, which is good. Okay, so if you want to have a realistic data in a not uh, long time. Okay, so I think that's all for this learning session, and I hope you learned something for this one. And thank you for listening, and see you in our learning session 3 or the next topic. Okay, thank you.